Hey, what is up you guys? codgamerMC here again, and today I'll be showing you how to establish a power plant generation plant in Electrical Age mod. So start off with, I'm gonna show you guys what I have here. So here what I have is a monitoring station around my power plants. Since my map is relatively very big, I need a monitoring station to monitor around all my power stations. So I currently have 6 thermoelectric power plants, and on this side I have a second unit because I have 2 units for each power plant. So I have a combo of 6, and here is like vapor equals steam. So here's the steam turbine units 1 and 2. So for example, each unit that I call unit is like 2 steam turbines and 2 generators, and then I have like a stone bricks on top and then 2 more steam turbines. So that's what units 1 and 2 are essentially, if you don't know. So to break it down right here, we have the voltage of the units, the percentage of throttle that it's giving the signal to maintain that voltage. So right here we have Costa Sur power plant. So for those that you don't know, I made in World Painter imitating Puerto Rico. So I'm imitating the Puerto Rico power grid right here. So Costa Sur will be right in the south of Puerto Rico. So we have the wattage of the thermoelectric power plant, the amperage, and the other units. So you can see right here, this indicates that when you lose the signal. So let's say right now it's 50, it means that the steam turbines are generating. If they stop generating, alarm will sound indicating that the power plant has shut off. So right here we have calculations, processors for calculating the actual energy demand and the percentage of generation. So maximum capacity of this system is 178 kilowatts, and right now it is consuming somewhere around 93 kilowatts. So right here we have the Mayagüez thermoelectric power plant. All of them are connected via transmission lines, meaning that if you see all of those monitors, they basically, you will see the same thing above 8 kilowatts for this unit. And this unit is only 1 unit, so 8 kilowatts. So each steam turbine is rated at 4 kilowatts hour. So we can assume that we have 2 steam turbines here and we have 4 over here. 4 times 4, 16 obviously. So the amperage and the percentage of each unit. So watching here Cambalache power plant, you can see it's above 8 kilowatts. The same thing as Mayagüez, and 4 kilowatts above. And then we have the Palo Seco power plant, and we have a stable 8 kilowatts here, and above 8 kilowatts on the second unit of Palo Seco. So we here have the San Juan wattage. It's a little bit above 8 actually, and here we have the wattage of the second unit. And then we have here Aguirre, which is also in the south, 8 kilowatts hour, and then we're here a little bit above 8 kilowatts. Most of the time it's around 8 kilowatts, just because the transmission lines interconnect the system, so making it more stable. And the voltage I desired is 3400 volts or 3.4 kilovolts. You can see it's not at 3.5, but almost there. It's 95% of the 3.5. So actually here we have the solar Aguirre. Since actually it's night, it's 4 a.m. right now, it's not producing anything, but when it's daylight it produces a little bit above 5 kilowatts. So here we have the breaker room for the monitoring station. Not much to go around. So this is like I said, the alarms, and then here I monitor the status of each thermoelectric, and when they start reaching almost 16 kilowatts, then I know it's time to up and put more units to produce more power and to stabilize more the system. So let's start showing you how to build a power plant. So as you can see right here, this is my road. So we're going to San Juan Thermoelectric Power Plant, which is just by the side. So as you can see here, a lot of cabling done. So arriving here at Central San Juan, you can see it looks like thermoelectric. So before we get into details, I want to show you the generation of the steam turbines are outputted here. So this is what each unit outputs, almost 3.4 kilovolts. So then it ups the voltage to 13.5 kilovolts, and then it goes to the grid converter and into the transmission line. And then the transmission line interconnects all around the island and interconnects again into a substation, transmission substation, which feeds these 13.5 kilovolt lines, which then go into other substations that lower the voltage into 3.2 kilovolts. As you can see here, this is a substation, transmission substation, and then a substation to transfer the voltage across. So right now it's morning and all of the lights have turned off, and as you can see the voltage is rising, is because the sudden increase in voltage means that since all the kilowatts that have been used in the night are no longer there, then it just accelerates. So as you can see right here, substation, and then it feeds the small grid, and the small grids then feeds the lamps via converters and lamp supplies. So as you can see right here, this is the 3.4 kilovolt line, feeds into a DC-DC transformer, and then feeds into a lamp supply that is fed via wireless channel to turn it on and off. So getting into building a power plant. So there are a few things that you should know about steam turbines. They are erratically crazy once they start up. They don't start, if you don't put it into consumption like the power produces, it will just inevitably explode, reach 4 kilovolts and explode. So here I have a steam array using power converters and the quantum solar panel steam generation, and then it goes into this room. So once on this room, you can see here that I have my controls. So I have a main switch and a bypass switch. What does this mean? The main switch is like the unit is turned on, so the main switch is on, meaning the unit is on. A bypass switch means a switch that I have to use to bypass the security system I implemented just because it can go crazy. And to prevent it from going crazy, I have a safety system. Once the breaker switches off, then the system automatically shuts off the turbines. So once they're off, it will be like this, but it will be off. So in order to restart them, I have to put the bypass switch on, and when I turn on the breaker and the voltage goes above 3.2 kilovolts, then I can shut off the bypass switch, and in case anything happens, then it will kick in and prevent the system from exploding. So right here, as I mentioned, it's 2 steam turbines and 2 generators. Starting on by this side, this is the grounding side, which is essential once the breaker switches off, then where all the power goes to ground. But you have to go through rheostats. So right here I built another place where I ground. I call it the grounding site. So here you have the grounding site, the rheostats, 64 coal dust, and just straightforward. I use 4 rheostats for every 4 units, like 1 for each steam turbine, grounded with high voltage cable, and in case anything happens, all the voltage goes to ground. So coming back here is a very complex system, and so basically they start off with the monitoring station. This is where I get the data from the probes. This is not necessary to run the system, but I want to monitor the system since it's really big. So this is straightforward. This is monitoring. monitoring and monitoring wattage, amperage, and voltage. So right here we have the throttle. Like I said, the throttle is like how much power, how much steam it needs to maintain that voltage. So my voltage is from 3.3 kilovolts to 3.41 kilovolts, and this relay here is where the system comes in. So this is the main switch, goes in this line to here, which kicks in this relay to connect this line, but the bypass switch is here. So when the voltage drops below 1.6 kilovolts, meaning when the breaker switches off, no voltage comes through here, so this is 0, meaning it closes this relay, which in turn closes this relay and then shuts off the steam to the turbine and grounds the unit so it doesn't explode. So right here I have the control for one, so in case, like I said, it loses power, then it like sends a warning to it. So right here we have diodes because we have the bypass switch and the control unit. So if you just connect them together, the voltage won't be stable enough. As you can see right here, it changes because of this. See, it's 50 right now, but if I were to not have the signal diode, then it wouldn't be 50, which in turn will just shut off the unit. As you can see right here, I did shut off the unit. See what the bypass switch does? If I turn it off, then it grounds the unit, but right now it's outputting some power to ground, but it'll stabilize itself soon, so no matter. So as you can see right here, so I have the bypass switch controller, meaning this will be 50 when I push the button and the rest of the system is off. And right now everything is 50 because it's above 3.2 kilovolts. So pretty straightforward what I have here. 2 steam turbines, 2 generators, and then we have here connecting the other units with the below units, as you can see right here. And then this bypass line also goes through a relay here that I call rebote, which means when daylight comes around, that the units start increasing in voltage, like I showed you around that it went to 3.5 kilovolts. So to prevent it from exploding, I actually have like another relay system that open and closes the grounding relay, so intermittently lower, like keep the voltage below 3.5 when that happens. So here's the grounding side. I have a relay. So the relay, what it does already mention it, it's ground the unit. So when it's closed, it actually grounds the unit, turning it off. So pretty straightforward, and this is not important at all. Like this line can be connected throughout, you don't need this relay. But since my system is really big and consumes a lot of kilowatts, then I need it for when the consumption is not there, to maintain the voltage in the units. So it is not necessary, this part. But to maintain the voltage stable, you need this bypass system, which with this security feature, and then this main switch. So main switch and then bypass, and when the unit is on, like it is right now, turn off the bypass switch, and it will just work its way like it would. And then right here, I have the output to diode and tower. It's important that you put that diode where it belongs, because if it's not there and the power plant just shuts off, then it might use the generators as starters, and it would consume some kilowatts and just basically shut off all the power plants. So it's important to use diodes, and then they go into the grid. So the important things here is the cable to breaker, and then the control for the steam turbines. Use a relay, and then have for the main switch, and then a relay on the main switch line, and then the bypass side which would make the system stable. And then it goes off to the grid. So basically this is about it on building power plant generation. And I have four other units. So I have a total of 4 units, and it's the same setup. Basically same setup, the relays, the main switch, the bypass switch, and the breaker. It's important that you install a breaker. And other important note on steam turbines, that if you're starting it off without anything, like it's not connected to anything, when it spins up, it will just explode. So it is important to synchronize the steam turbines into a grid. Let's say you have a small grid, so you should go about it depending on the consumption. Each steam turbine outputs 4 kilowatts. So right here I have 8 kilowatts, then 16, and then it goes 24, 32 kilowatts. So it is important, let's say that your grid consumes 6 kilowatts, or let's put it more simple, 2 kilowatts. So all you need is 1 generator and 1 steam turbine. Follow the same system that I have here to control the steam turbines. But when you start the steam turbines, you have to synchronize them. So on my case, since I have the rebote side, the voltage would increase above 3.5, then this would kick in to ground some of that energy to maintain the voltage stable, and it will eventually stabilize itself. But if you don't have that system, then what you need to do is be really aware of the voltage, and once the steam turbine kicks in above 2.5 kilovolts, then just be attentive that the voltage will spike up rapidly, and then you will have to manually close and open the relay to put some of that energy to ground. So my recommendation is that when you synchronize it on a small system, you open the relay and then watch the voltage, and then close the relay again, watch the voltage until it stabilizes itself and it's able to do it on its own. So that's all about steam generation. There are not many of steam turbine power plant setups, so this is my setup. If you want to copy it, you can. The grid is really big, to mention it. I want to show you around some of the grid that I have. So that 13.5 kilovolt grid goes into a substation to feed the 3.2 kilovolt regular grid that goes on here, and then the transmission lines just go all around the island, connecting every other power plant generator. So to show you around pretty quick, this is San Juan area, and I'm gonna teleport to the Maya West power plant, which is where I have the rebote. So we're here at the Maya West power station. Same thing as the San Juan one, the breaker and the system. This looks more complex just because I don't have it organized, but it's the same system as in San Juan. And then on the grounding side, the ground is outside of the power plant, since I don't have a lot of space here. And so the rebote is right here. So it originates here and then I transmit it all around. So the rebote is when it increases above 3.53 kilovolts, then the system intervenes and it closes itself at below 3.49 kilovolts, just maintaining the voltage stable at 3.4. So that's about it for the rebote. And you can see here we are basically thousands of meters away from San Juan, and we still have here the transmission lines that go into substations. Like I said, these are our main substations. I'm gonna show you what I mean. So we have here transmission, and then we have here distribution that goes into the substation, which goes into 3.4 kilovolt. But here we have this distribution of 3.6 kilovolts go to another substation, because Maya West is one of the areas that consumes a lot of kilowatts. As you can see, the transmission lines input like 10 kilowatts from around. So right here it's 5 kilowatts and going to this substation. As you can see right here, this line then goes into a substation that feeds the 3.4 kilovolt grid. So you can see breakers all around. And then the reason why I have this substation here is because I have this 3.4 kilovolt grid feeds a lot of electricity this way, and then I have a neighborhood this way which actually consumes around 3 to 4 kilowatts hour. It doesn't consume much in the day because I have a house with solar panels, but it's a subterranean electrical grid for this neighborhood. So going to Costa Sur right now to show you more around the same power. So right here we have the Costa Sur power plant. It's just the same as San Juan power plant, same units. You can see the units right in there, same thing around. And then on this side I have the output to the grid, same thing, 13.5, and then it goes into the transmission grid and to the substation and then to other substations. So to show you around a really small grid, I'm going to show you the Culebra grid, which is inevitably the smallest that I can show you around. So we're arriving here at the Culebra power plant. It's a really small unit that only uses about almost 3 kilowatts hour. So right here I have 4 units for 8 kilowatts, just because I didn't want to, or it's like put some of the, so this steam turbine is not working, so I put some of the kilowattage from this generator into that side, so to use almost the 4 kilowatt it allows to, so it stabilizes the system. So how did I go about stabilizing the system around here? It's the same thing. I made a rebote. So this works independently of the rebote of my OS, since I don't have the retransmitters on. So what it does here is that when it increases the voltage, it opens ground and it will maintain a stable voltage of 3.4 kilovolts. So as you can see, if this were off right now and I were to turn it on, then it would just spike like crazy and explode, just because the consumption is not a lot. Because a single generator can output almost like 16 kilowatts full charge, so that's what I mean. It would explode if it's not synchronized correctly. So right here I have the rebote control, and then I here have the rebote control, and then here I have the Culebra bypass turn off and turn on. So right here I have the main switch to the bypass system, which goes to the bypass system, and it's really small, so it will, with the rebote, it will stabilize itself on its own. It might explode, it might not. I haven't tested it using that since the grid is big, but here I did test it on rebote and it worked perfectly. Once the turbine spinned up and spiked to 3.5 kilovolts, then the ground opened and it kept going back and forth until the 3.4 kilovolts was reached and it stabilized itself. So right now it's stabilized, and then so it outputs to small grid. So this grid is really small in the 3.4 kilovolts vicinity. So that's it about steam generation power plants, and just be careful with steam turbines because they tend to explode a lot, and it's a lot about trial and error. This is not a system that once you put it will work guaranteed. It will work correctly guaranteed, but it won't work perfectly if you don't know how it works. You gotta know how it works, like manipulate it until you get what you want. Like I showed here, you can copy this system and I will guarantee it will work, but just gotta be careful that it might explode or it might not. So just be very careful with steam turbines since they tend to explode a lot. So good luck on building your own grid, and just be careful, put a lot of breakers that will ensure that the grid does not explode. So just be really careful about it, and I will see you guys in the next video. And if you like this video, please comment down below, like the video, subscribe to my channel, and just comment how this video was and how it helped you out. So see you guys in the next video. Peace.